Let f of x equal 25 minus x squared. Use the limit definition of the derivative to find the slope of the tangent line at negative 5, 0. Then determine the equation of the tangent line at negative 5, 0 in the form y equals mx plus b, which is slope-intercept form. So one method to find the slope of the tangent line at x equals negative 5 would be to find the derivative function using the limit definition of the derivative shown below, and then evaluating the derivative function at x equals negative 5. However, we can find the slope of the tangent line in one step by substituting negative 5 for x in the limit definition of the derivative, which will give us f prime of negative 5, which will be the slope of the tangent line at x equals negative 5. So taking this approach, we can find the slope of the tangent line in just one step. And that's what we will do in this lesson. The slope of the tangent line m is equal to f prime of negative 5, which is equal to the limit as h approaches 0 of, in the numerator we have f of the quantity negative 5 plus h minus f of negative 5. In the denominator we have h. And now to evaluate the functions in the numerator. To evaluate f of the quantity negative 5 plus h, we replace x in f of x with negative 5 plus h, which gives us 25 minus the square of negative 5 plus h. And then we have minus f of negative 5, which needs to be in parentheses. We have 25 minus the square of negative 5. And all this is still divided by h. And now we need to begin simplifying the numerator. Let's begin by squaring negative 5 plus h. To square negative 5 plus h, we have two factors of negative 5 plus h. When multiplying two binomials, we have four products: 1, 2, 3, and 4. Negative 5 times negative 5 is positive 25. Negative 5 times h is negative 5h, giving us minus 5h. H times negative 5 is negative 5h, giving us minus 5h. And then we have plus h times h, which gives us plus h squared. And notice how we do have two like terms. Negative 5h minus 5h is negative 10h. So going back to the limit, in the numerator we now have 25 minus, in parentheses, the square of negative 5 plus h, which we now know is 25 minus 10h plus h squared. Then we still have minus the square of negative 5 is positive 25, giving us 25 minus 25. And again, this is still all over h. There's another close parenthesis here. Now we will close the parentheses here. Because of the subtraction, we need to either subtract each term or think of distributing a negative 1. So distributing negative 1, we have negative 1 times positive 25, which is negative 25, giving us minus 25. And then negative 1 times negative 10h is positive 10h, giving us plus 10h. And negative 1 times h squared is negative h squared, giving us minus h squared. And then we have minus, but notice 25 minus 25 is equal to 0 all over h. Also notice how we have 25 minus 25 here. That simplifies to 0. So now we have the limit as h approaches 0 of the quantity 10h minus h squared, all divided by h. But notice how 10h and h squared have a common factor of h. Let's factor out the common factor of h, which gives us h times the quantity 10 minus h all over h. So the reason for factoring the numerator is now we have a common factor of h between the numerator and denominator that will simplify to 1. If this factoring was confusing, another option would be to break this up into two separate fractions by dividing the monomials in the numerator by h. Notice how if we have 10h divided by h minus h squared divided by h, we still have 10 minus h. So we have the limit as h approaches 0 of 10 minus h, but h is going to 0, and therefore this limit is equal to 10, which indicates the slope of the tangent line at the point at negative 5, 0 is 10. So we know the slope of the tangent line is 10. So for the equation of the tangent line, we know y is equal to 10x plus b. We still need to determine b, the vertical or y-intercept. Notice the point negative 5 comma 0 is not the vertical or y-intercept. But we can use that point to determine b. Since negative 5 comma 0 is a point on the line, when y is equal to 0, x must equal negative 5. So performing substitution, we have 0 equals 10 times negative 5 plus b. So again, we substituted 0 for y and negative 5 for x. This gives us 0 equals negative 50 plus b. Adding 50 to both sides to solve for b. We now know b, the vertical or y-intercept, is positive 50. And therefore, the equation of the tangent line at negative 5 comma 0 is y equals 10x plus 50. And before we go, let's verify this graphically. The graph of the original function f of x equals 25 minus x squared is graphed in red. The tangent line y equals 10x plus 50 is graphed here in blue. Notice how the blue line is tangent to the red curve at negative 5 comma 0, verifying our work is correct. I hope you found this helpful.